All right, Casey. We start with you guys. Make sure y'all get some donuts now. I ain't but 3 of y'all, but I need you to like suck it up and take 4 for the team. Casey, your body is much more quick to handle than mine. All right, Casey. All right, we start with you guys. Make sure y'all get some donuts now.
Casey,
I ain't but 3 of y'all, but
what
I need you to like suck it up and take 4 for the team.
That this one is working a little bit differently.
Casey, your body is much more quick to handle it than mine.
Okay, and the reason why is
Alright.
because both of these can be written as base.
So Casey, the first one,
so I can get
what we're interested here is noticing that
cannot.
this one is worked a little bit differently than this one is.
Anytime you have a fraction.
Okay, and the reason why is
general
because
rule,
both of these can be written as base
you're going
5.
to want to switch it from a
So I can
fraction
get those
to
into the same base.
next one.
These I cannot.
So you're going to have 25.
Okay. Anytime you have a fraction, as a general rule, you're going to want to switch it from a fraction and make it a negative exponent. So you're going to have 25.
You're going to have 25 to the 3x minus 4 equals 125 to the negative.
You're going to have
2x.
25 to the 3x minus 4 equals 125 to the negative 2x plus 1.
To the
Does that make
3x
sense?
minus 4. 125 is 5 cubed.
Now 25 is 5
To
squared.
the negative times
3x
negative 2x
minus 4.
plus the 2x.
125 is 5
1
cubed.
negative 1.
To the negative times negative 2x is positive 2x. Negative times 1 is negative 1.
Now, this is 5 to the
Okay?
6x minus 8
Now,
equals
this is 5 to the
5
6x minus 8
6x minus
equals 5 to the 6x minus 3.
3. Okay, the answer is actually no solution.
What's that? Okay, the answer is actually no solution.
Yeah, that's what I was confused. I did it like 3 different times because I was like, this
Alright.
is silver.
Yeah, the answer is no
We good?
solution.
Can I erase it?
Alright. We good? Can I erase it?
Yep.
We got 5 to the x minus 3.
We got 5 to the x
7
minus
to the
3
plus 4.
equals 7 to the x plus 4.
I'm going to take the element of both sides.
I'm going to take the element of both sides.
That comes in front.
That comes in front.
Can you use log or do you have
No, you can use
No,
one.
you can use log.
Okay.
Just when I
Just when I get the answer,
everywhere
everywhere I have ln, you just put a log.
Okay.
And it's the same thing. Alright.
X
X ln 5 minus 3 ln 5. X ln 7 plus 4 ln 7. Subtract x ln 7. Move that over. So you're going to get x ln 5 minus x ln 7 equals 4 ln 7 plus 3 ln 5. Yeah? Factor out the x. And we divide by ln 5 minus ln 7. ln 5 minus ln 7. Alright. Make sure you have it.
Yeah, okay. I think I did something wrong. Maybe.
What did you get?
Alright. Log 3 plus log 4 over log 5 minus log 7.
You got what?
I got log 3 plus log 4 over
Yeah,
log
definitely
5
not
minus
that.
log 7.
Definitely not that.
Yeah, that's why I was like confused.
Alright.
Combine
These as multiplication. You're going to get x times x plus 3, which is x squared plus 3x, equals 1. Yeah. This is base 10. So x squared plus 3x equals 10. X squared plus 3x minus 10 is equal to 0. X plus 5. X minus 2 is equal to 0. gives you x equals 2 and x equals -5. You agree?
Yeah, sure. I didn't go that far, so I got something completely different.
Yeah, you want to combine them using the properties of logarithms.
Oh, okay.
Then you want to do the change them from a logarithm to an exponential, which is always the case. If we have exponential, we switch to logarithms. If we have logarithms, we switch to exponentials.
Oh, that makes sense. Okay.
So once I switch to an exponential, I get this. Right? This is 10 to the first power equals x squared plus 3x.
Oh, okay. Okay, so we're wrong. Thank you.
Alright? Then you factor. But here's the deal, Casey. -5 doesn't work, it's not in the domain. The domain for that is 0 to infinity.
Oh, because
You can't have a negative number that doesn't
Oh,
exist.
okay. Yeah.
Alright? You good? Do I need to leave them up for you to look at? Maybe for a minute?
Yeah.
Alright. Look at them when you're ready for your race.
Okay.
Kyle! We're at the cube root of 64. We're raising that to the -2. Cube root of 64 is 4. 4 to the -2 is 1 over 16. You good? Here, we'll multiply the exponents. Top part is x to the 4/3. The bottom part is x to the 4/5. We agree? We subtract smaller exponent from bigger exponent. So it's going to be x to the 4/3 minus 4/5. Up, over 8/15. Okay. Was it in the subtraction or did you mess up before that? Okay. Let me know when you're ready to move on. All right. What did you get for the domain of that?
-805 to infinity.
Perfect. You set this greater than or equal to 0. 5x is greater than or equal to -8. Divide by 5, divide by 5. X is greater than or equal to -8. All right. You good? Ready? Casey, you good?
Yeah.
Tyler, you have pre-calculus yet?
Yeah, I already took it.
Okay.
I'm about to take calculus 1 at UCF this summer.
Okay. Hey, look, now you say my email. If you have questions, you let me know, okay? All right, Casey. Sketch x minus 2 squared plus y plus 4 squared equals 25. Find the domain and range. And find the center and the radius for x squared minus 8x plus y squared plus 2y equals 3. Alright? Kyle. Let's go break this down. Square root of 84. X to the 12th, y to the 19th. Let's go square root of 3. Square root of 2 minus 4. No, minus 6, excuse me. And then let's go, square root of 8 minus 5 square roots of 72 plus 4 square roots of 27. Alright, Kyle, that's you. Kyle, you ready? What was cosine?
The only one I got was cosecant.
I'm not laughing at you, but you should have gotten cosecant, right? That's what we're sine, so. So let's take a look. Why do I tell you it's in quadrant 2? Okay, why do I tell you that? See, sine can be positive in either quadrant 1 or quadrant 2. But depending on the quadrant, Tyler, depends on whether or not the remaining values are positive or negative. Does that make sense? So by the fact that I tell you it's in quadrant 2, tells me that this is 3/5. So you've got a number of ways to handle this. You can either utilize the fact that sine squared theta plus cosine squared theta equals 1, or you can draw the triangle and do Silva. Which way would you prefer to do it? Triangle? Okay. So if we do a triangle, if this is theta, sine theta equals 3/5. So opposite over hypotenuse.
Should I do diagram theorem or should I do like a different way?
Pythagorean theorem. All right. You want to go ahead and try it?
Yeah, I'm gonna do it.
All right, go ahead and do it. Casey, you ready? Okay, take your time.
I'm getting close.
I wasn't Sonic this morning, Casey. There was like 12 cars in the drive-through. I was
You
like,
go to Sonic for breakfast?
every morning.
What? I've never had their breakfast. That's okay.
They have the best ice and some really good water.
That's what my friend said. You can like buy their ice, like a bag of it, for like $2 and something cents.
Yeah.
I didn't know.
So we remodeled our kitchen, and Roberta said, we need to get an ice machine that makes Sonic ice.
Yeah,
And I'm like, that's a good idea.
that's the goal.
Casey, these things are $5,000.
They are?
I was like, no, baby, I don't know about no damn ice machine that's $5,000.
Oh, heck no. That's too much.
So I started the GoFundMe.
Oh, no.
So far, I'm at $0.
See, if I had money, I would help your cause, but I'm broke as well, so.
Yeah, I mean, everybody seems to be.
Yeah.
I can't even find a sponsor for my SOS. Were you there Wednesday?
Is this one?
Yeah.
I was not.
Tyler, were you there Wednesday?
Yeah, I was.
Hey, do you get a sandwich?
I don't believe so.
You don't eat Chick-fil-A?
Not really. I hardly eat. I eat it, but like hard.
Do you not do it for personal reasons, or are you just kind of healthy?
Kind of healthy.
I'm trying to be healthy, Tyler, I'm trying. Did your dad do the challenge of health cupcakes?
Yeah.
Is he just going there?
He's also doing a challenge, and yeah, he cheated last night. He was supposed to, he ate like 2 little baby cakes. Which honestly, I understand that.
The little Debbie cake, that temptation is strong.
It is, it really is.
I was so glad when I got the Sonic and they were busy, I couldn't get breakfast this morning. And my next stop was a donut place, and I was like, oh no, I can't have a donut.
Okay, I think I got it.
So I didn't have a donut, Tyler. I stayed strong. From now on, Casey, I'm gonna say what would Tyler do?
Good, yeah.
Alright, so go to sine theta negative 4/5, right?
Well, I didn't do the it's supposed to be 42, so
Yeah, cosine the x value, right?
yeah.
So Tangent theta would be negative 3/4. Cotangent theta is negative 4/3. Secant theta, negative 5/4. Cosecant theta is negative, or positive 5/3, yeah? So we're good on those.
Yeah, it's pretty easy now.
Alright?
I just don't like that equation up there. With a triangle, it's way easier.
Yeah,
Yeah, that's true.
Alright,
So let's find sine 2 theta and cosine 2 theta. We couldn't do it on, we should have choose it today. He's supposed to weigh in today.
He is?
Yeah.
Oh no, oh no. Oh well. Okay, I'll learn his lesson.
He's doing well now. How old are you today?
Like 57?
Yeah, he's doing well.
Yeah, he's trying to do well. He's doing well.
I mean, I saw him work out. He was getting after it pretty good, so.
Oh, that's good. Yeah, he does multiple workouts a day, so he's doing well. I think I did the first one, right?
Okay.
I think it's the second one I did okay.
Alright, let's take a look. The center is gonna be 2, negative 4, do you agree? And then we're gonna go 5 in all directions. Right? So if I start at 2, and I go 5 this way, that takes me to here. 5 this way, takes me to here. 5 down, takes me to here. 5 up takes me to here. And I totally misdrew that, but.
It's a good circle.
Much better. Alright. Is that how you did it or no?
Yeah, I do like that.
Okay, so now what's the domain?
I got 2 to infinity.
No.
Oh, no.
So, infinity you would have to have an arrow. There's no arrow on this, right? How far left does it go? The farthest left-hand point is negative 3.
Oh, okay.
How far right does it go? Well, the furthest right-hand point is 7. Negative 3 to 7. So essentially all you're doing, Casey, is you're starting at 2, you're adding 5 to get to 7, you're subtracting 5 to get to negative 3.
Oh, okay. That makes more sense, yeah.
Right? And then you're starting at negative 4, you're adding 5 to get to 1, you're subtracting 5 to get to negative 9. Does that make sense?
Yeah, I don't know. I thought it was infinity, but.
No, it's all good. No judgment. Negative 9 to 1. I mean, the thing is, Casey, when you're in doubt, infinity is usually a pretty good answer. Because infinity shows up at about 90%. Right? Like, if it ain't negative infinity to infinity, it's some number to infinity.
Yeah.
So, no, I mean, anytime I'm asking for doing a range, infinity is usually a pretty good answer to have somewhere in there. Alright. Now for this one, we have to complete the square, yeah?
Yep.
So we're gonna cut this number in half, and we're gonna square that. Negative 8 divided by 2 is 4, 4 squared is 16. So we're gonna go x squared minus 8x plus 16, plus, cut this number in half, y squared plus 2y plus 1. 2 divided by 2 is 1, square that, you get 1, equals 3, plus 16, plus 1. We agree? So the center then becomes x minus 4 squared. This factors to x minus 4 squared. This factors to y plus 1 squared. And that's equal to 20, yeah?
Yeah.
We have 4, we have negative 1. That's our center. We have 4 negative ones our center. Our radius, 2 square roots of 5. Square root of 20, which is 2 square roots of 5.
Okay, yeah, I got that.
Alright, you good on that?
I think so, yeah.
Sure?
I got that on the first one, but the second one was good.
Do we need to do another one like the first one? She should be the only one here, so you get to make a call how what we're doing.
Yeah, maybe one more the first one.
Okay? Can I rate both? Can I rate both?
There could be more people here with the final round next week.
You know, Tyler, I'm going to say this with a great deal of love in my heart. I was driving over today, and I was thinking about how blessed I am. On a number of levels, I'm very blessed. And I spent my first year teaching at Lake Region, teaching high school. I suffered through 1 year of that shit. You know what I mean? And I came to the college, and I'm thankful for the fact that I don't have to teach people who don't want to be here. You know what I'm saying? I just don't have to. It's just not. You don't want to be here? Deuces. The interesting thing is, and I think part of it is COVID.
Yeah, that's true.
The interesting thing is that in semesters past, these sessions were full. Like some semesters I had to buy 2 dozen donuts. On the last day I had to buy 3 dozen donuts. Because we had 30, 40 people here. I know Vanguard cut the ride out. So the people who generally would come from Vanguard don't have a ride anymore. But you know, I'm thankful for those who want to be here who show up. Because if not, I would have donated the donuts to somebody and I would have done work today. But yeah, no, you would think that I'm blaming it all on COVID. That is my go-to answer. Oh, too much. All right, Casey, here we go. So sketch that, find the domain and range. Find the inverse. If f of x equals 7 over x minus 4. Alright. But you know, Tyler, I'm surprised on Wednesdays there's not more people. You know, I mean, it's after class for a lot of people. I mean, they're on campus already.
The one class I went to, it was actually pretty full.
When this?
It was like not this week, but the last week.
Yeah, there was one that was like this week. Last 2 weeks haven't been very well attended, really.
Really? I thought, like, compared to this class, it seemed like super full. I was like, dang, that's a lot of people here.
Yeah. But one thing I'll never regret doing is trying. Right? Can't regret trying. You know what, Kyle? you can't say that he didn't try,
Right?
right? I mean, people can say whatever they want to, they can't go like this, well, he don't care, he didn't try. No, I tried. So, you know, sometimes life is a buffet, you take what you want. Kyle, what'd you get?
I got 28x to the power 6, y to the power 9, square root of 3y.
Okay, I like the x to the power 6. I like the y to the 9th with the y left over. The part I don't like so much is the 28. Can you walk me through what you did? You broke down 84, how did you do that?
3 and 28.
3 and 28. That is 84, yes. Now, how did you break down 28?
The only way that I really knew of was 7 and 4.
That would be the way I would do it.
And
And then what did you do from there?
Oh, I see where I messed up. Because I could have kept going with 4 and breaking that down.
Yes.
into 2.
Yes, that's what you want to do. So you want to break this down, and then you're going to get 2, and then you're going to have 21 on the inside. All right. Now, I like the x to the 6. That's because 12 divided by 2 is 6 with the remainder of 0. I like the 9 with the remainder of 1. So the 9's on the outside, and the 1's left over. All right. Here, square root of 6 minus 6 square root of 3. Did you get that? That one's actually a little bit tricky. Because the 6 isn't under the radical. So it kind of throws people for a loop a little bit. All right. All right. 8 is 4 times 2. So this is 2 square root of 2. Minus 30 square roots of 2. Plus 12 square roots of 3. Do you agree? Okay. So got to combine these two. Got to combine those two. Can't combine the square root of 3 because it's not a like term. Okay? All right. Kyle, anything in that topic, I mean, I can keep giving you problems. I have no problem giving you problems. All right, I'm relatively skilled at just making up problems. Is there anything that you want to see? I mean, you're the only one here, so if there's something that you want to look at, some material that we went over that you thought, you know what, I'm just not sure about blank. Tell me what it is, let's look at it. All right. What'd you get, Tyler?
Alright, so this is the answer I came up with.
All right, let me hear it.
Sine is at, I was thinking it's 2 sine, or it could be like 2 pi. I was thinking that could be like 0 since it was on the unit circle is 1, 0. So I was thinking that could be 0.
Yeah, but we're using this information.
What is it?
We're using this information. Use all of this to get these two.
So would I use, so would that be like 3/5 sine 2 or something? No, sine 2, 3/5, like how do I do that?
So, double angle formula, yeah? Sine 2 theta is 2 sine theta cosine theta. You want to commit that to memory. We use that quite a bit. I've tried to always be honest with you, Tyler, about what you need to know and what you don't need to know. Sine 2 theta, definitely want to know. Pythagorean identity, definitely want to know. Alright, not just for the final exam, but as you go through calculus, you see this thing all the time. And we use it quite a bit. Cosine 2 theta is cosine squared theta minus sine squared theta. Which is 2 times 3/5 times -4/5, which is -24/25. Yeah?
Why is it cosine squared theta, then on the sine it's just 2 times sine theta? 2 sine theta.
Oh, why is the formula different?
Yeah.
It's because of the way cosine A plus B works. Cosine A plus B is cosine A cosine B minus sine A sine B. And so, when A and B are the same, you get cosine squared minus sine squared. Alright? So this is -4/5 squared minus -3/3/5 squared. So we get 16/25 minus 9/25 equals 7/25.
That's from test 2 or test 1?
Test 1.
Okay.
Well, okay, so this was test 3.
Yeah, test 3 I didn't get that at all.
This was test 3. This was test 1.
Test 1 I did pretty good. Test 2 and, no,
Test 2 is graphy.
test 3 and 4 I didn't do that good.
Yeah, this was off of, I want to say it was test 4 maybe, or test 3, it was one or the other.
Yeah, those 2 I didn't do good. The first 2 I did good and the last one.
Yeah. I'm assuming we can erase this.
Yeah.
Find the domain and range of tangent 2x minus pi over 3. And then arc sine equals negative square root of 3/2 equals what? Oh, Kyle, what are we working on?
The biggest one that I mainly had the most trouble with, from last class, not the newest one we started, but the one previous. Which was like the square roots times 4 minus like square root of 6.
Okay, so the multiplication, like kind of like what we just did.
Yeah.
Okay. So let's go square root of 5, square root of 10 minus square root of 15. And let's go square root of 2 plus 3 squared. And let's go square root of 6 minus square root of 7 times square root of 6 plus the square root of 7. Let's try those 3. Alright, Casey, you ready?
Yep.
Alright. This shifts which way?
Actually, it goes to the left.
Goes to the left 4. Alright. Up 2, yeah? Then which way is it gonna go?
It shifts in all directions 9.
It's in all directions 9. We good? What's the domain?
I got negative 13.5.
Nice. Negative 13.5. What's the range?
Negative 7 to 11.
Nice. And versus that?
Oh, that, okay. I got 7 over x minus 4.
So you get the same thing?
Wait. Maybe, wait. Maybe it's 3 over x? I don't know, I already did it multiple times, I got multiple answers, so.
Alright, so you swap the x and the y, right?
Yeah.
Multiply both sides by y minus 4, you'll cancel here. So you got xy minus 4x equals 7. xy equals 4x plus 7. So your answer is y equals 4x plus 7 over x.
Oh, I did distribute it. I'm not sure. Okay.
If you don't distribute,
I took the x out, I got x and then parentheses y plus 4.
if you don't distribute, you get 7 over x plus 4.
Yeah, that's what I got.
That's fine.
Wait,
That's correct.
what? It is?
Yeah, when you said 7 over x plus 4, I thought you meant 7 over x plus 4. I didn't realize you meant 7 over x
Yeah.
and then plus 4.
Oh, okay. Okay, got you.
Does that make sense? The way you said it, you didn't say it wrong. It's just the nature of communicating math.
I misunderstood how you're phrasing it.
So you don't have to like distribute?
No, you don't have to.
Okay.
I mean, unless the answer shows up like mine and not yours.
Okay. Okay, sounds good.
All right. What the flip?
All right.
Casey, anything in particular you wanna see?
Probably logs, because it still messes me up a lot.
Okay, so, alright, let's go here. That bottom is Z plus 2.
Okay.
Okay, Z plus 2 raised to the 4. Kyle, you ready? Alright. Top is square root of 50 minus the square root of 75. 50 is 5 times 10, 10 is 5 times 2. And you're going to get 5 square roots of 2. 75 is 5 times 15. 15 is 5 times 3. So you're going to get minus 5 square roots of 3. Are you good? Alright. This is square root of 2 times 2 is 2. Plus 3 square roots of 2. Plus 3 square roots of 2. Plus 9. So this is 11 plus 6 square roots of 2. Kyle, you see that?
You see where I went from?
Okay. You sure? Alright, here, square root of 6 times square root of 6 is 6. Plus the square root of 42. Minus the square root of 42. Minus 7. You agree? Middle terms cancel. 6 minus 7 is negative 1. Good?
Yep.
Alright, Kyle. Let's try this. Let's go back to that one that kind of threw you for a loop a little bit. Alright. Let's go back to that. Make sure you can practice that. Then let's rationalize. Alright. Beat your ass, didn't it? You know why I did that, right?
Because
You just told me you did well on test 2.
And I was
like,
oh,
let's go ahead and throw some test 2 stuff up there. Although, the other one I think is test 3.
I got the sign -1. It's negative 5 for 3. I got the range for the first one. It's negative infinity positive.
Yes,
the range for the first one's negative infinity to infinity. Hey, see, Casey?
I'm
I'm telling you, just getting that infinity in there is a good idea most of the
Yeah, I
time.
agree.
Alright, so the range for this is definitely negative infinity to infinity. Where the struggle will occur is on the domain. The domain's a lot harder. Alright? So first thing we want to do is take out a 2, make this x minus pi over 6. Right?
Got that.
Now, what that tells me is, remember that with tangent looked like this, where this asymptote is at pi over 2. Right? And the period for tangent is usually pi. So we start at 0, and then we go pi over, and we're at our next point. Does that make sense?
I got stuck at the next point. I did.
Okay, so your next point is going to be at pi over 2, and so here's the deal. It's, you're going to start at pi over 6. Your next point's going to add on pi over 2.
Why is that when you add pi over 2?
Well, you're generally at pi, but if there's a number in front of the x, you got to divide that period by the number in front of the x. So your new period becomes pi over 2.
Okay.
Okay? So this is 2 pi over 3. If you add that together. You agree?
Yeah, I think I had that on my notes somewhere. I'm trying to do that.
So this is 2 pi over 3. 2 pi over 3. So this is, the first asymptote occurs at,
The first asymptote would be half of between 5 or 6 and 2 over 0.
yes, 5 pi over 12. And then it's going to carry on every pi over 2 after that. So the domain is all reals except 5 pi over 12 plus k pi over 2.
So what's the k pi over 2?
Well, usually it would be k pi, period is pi.
Yeah.
So k pi just takes you in advance of the past.
So most of the time the answers always have k pi.
Yes, usually it does. If it's tangent or cotangent or secant or cosecant. Sine and cosine, the domain is negative infinity to infinity. But because the period changed, then you gotta adjust the asymptote based on the period.
Okay.
Alright? You good? Alright, what about this one?
That's negative pi over 3.
Negative pi over 3. Negative pi over 3. I'm gonna do it now. Erase it. Alright, let's go here, Tyler. Let's go, let's go tangent, arc sine, x over 5. Let's go tangent, arc sine, x over 5. Let's go sine squared theta. Equals 1. Find theta. All right.
Okay, so we ready?
I can't remember why I don't like logs. I'm like, the first one I kind of got stuck on, and then I think I know some of the second one. Like I just got done.
Alright, so log starts at 1 and goes this way.
Okay.
Alright. Alright, so this is just going to shift it to the right 4 units. So instead of being at 1, we're going to be at 5. We'll have an asymptote here. Alright.
I just solved for X, because I couldn't really go from there.
Good? Good?
I think so, yeah. Wait, is the asymptote at
4.
4? Okay.
Asymptote is whatever makes this equal to 0.
Oh, okay.
To split these up, anything on top gets positive, anything on the bottom gets negative. Right? Anything on top gets positive, anything on the bottom gets negative. Then we split them up. Now exponents come to the front. Okay?
Yeah. I got that wrong also.
Dang, Casey.
Yeah, I suck at logs. I don't know what I'm doing with these.
Good thing the test is this weekend.
It's today.
What do you have till Sunday?
I think I could find it.
Alright, you good? Alright. Alright, Casey, I'm gonna give you one more set, okay?
Okay.
Combine that into 1. Right as the logarithm. Use change in base and evaluate. Alright. Kyle. Square root of 5 minus 6 times square root of 5 minus 6. Give me 20 minutes. Square root of 5 times square root of 5 is 5. Minus 6 square root of 5. Yeah? Minus 6 square root of 5 plus 36, yeah? So we got 41 minus 12 square root of 5. You
You got that?
Yep.
Good. Alright. So we're square root of 5 over the square root of 7. So we've got the square root of 35 over 7. This one I don't know if you've seen.
Yeah, I've seen one similar to it,
Okay.
but not that exact one.
Okay. So you did see this one though. We did this one in class. Okay. So this and this are very similar, except that you have to multiply by whatever this is and change the plus to a minus, or change the minus to a plus. It's called the conjugate. All right. Now, what I tell students, Kyle, is don't distribute the top. Don't be in a hurry. A lot of people like to do the part they know first. Don't distribute the top until you take a look at the bottom. Here's the reason why. Square root of 3 times square root of 3 is 3. Minus the square root of 3 plus the square root of 3. Those will always cancel if you do it right. Alright? Plus 1 minus 1 is minus 1. So you have 2. Square root of 3 minus 1 over 3 minus 1 is 2. And the reason why I don't want you to distribute is because you might be able to cancel. Okay? And so you get square root of 3 minus 1. Alright? You good? Alright. I'm gonna leave that bottom one up and give you one more just like it, okay? All right, Tyler. What'd you get for the first one?
I got square root of 25 minus x squared over x.
I like it. This is theta. Opposite over hypotenuse. This is 25 minus x squared. No, I don't like it at all, actually. Huh?
Let me see.
Did you draw a picture like this?
Yeah.
Well, what's tangent? Tangent is what?
It's sine over cosine.
Well, yeah, it is, but it's also opposite over adjacent, right? So it's opposite over adjacent. Yeah?
Is the minus x squared always out of the square root?
It's inside. It's inside, you just can't tell.
Okay. Okay.
You got it? What'd you get for that last second one?
I'm gonna just guess on this one. I got sine theta plus 1 times sine theta minus
You got
You got what?
Sine theta plus 1 times sine theta minus 1
That-
equals
that-
0.
okay.
Okay,
And
how do you solve that?
I don't know. I got that right there.
Okay.
Okay, so then
You
you got sine theta plus 1 is equal to 0,
and
and sine theta minus 1 is equal to 0, right?
Yeah.
So
So sine theta is equal to 1
equals
equals negative 1,
and
and sine theta equals positive 1, yeah?
Yeah. Then it'd be like
So
So when is sine theta equal to negative 1?
So
So sine is the y value, yes?
yeah.
So when's it negative 1?
Would it be like 180?
No, that's cosine.
Sine
Sine theta is equal to negative 1 at 3 pi over 2,
right?
right?
Yeah.
When's equal to positive 1?
It'd be, it'd be 90. So they just find where sine and negative 1 equals that.
Yes.
Yes,
I
Yeah.
get that.
yeah. All right, you good? All right. Anything else? I'll give you one last set. Anything that you really want to see? Go on your notes. Let me do these with Casey. Casey, you ready? And if you're not, it's okay, because Tyler's going through his notes.
Yeah, I'm not doing too well.
Okay, it'd be like where you did sine times a plus b equals sine a, cos b plus sine b, cos a, that type of stuff.
Sine A plus B equals sine A cosine B. But yeah, that was kind of what we did early on with sine 2 theta and cosine 2 theta. But let's take a look. All right. So we got sine theta equals 3/5, or sine A equals 3/5, cosine A equals 4/5. Sine A or sine B equals 1/2, cosine B equals negative square root of 3/2. Okay. Find sine A plus B and find cosine A minus B. All right, those will be your last two. All right, Casey, let's roll. So anything that's plus goes where? On top. Anything on plus goes on top. Anything minus goes to the bottom. Numbers will always go up as exponents. So we have ln x squared, this is a plus, y to the 7th over z to the 4th. All right.
Okay.
All right. Write this as a log. It's log base x minus 7
5y equals 5. Log base x minus 7,
Oh.
and then swap these two. 5y equals 5.
Oh, okay. Yeah, I just think they're way more complicated.
Yeah, you gotta know those properties.
Yeah.
What's the change of base rule say?
Is that this, that's 50. I don't know, I just put like 7 equals 12, that's as far as I got.
So the change of base rule says that log of base 7 to 12 is equal to log 12 over log 7, or ln of 12 over the ln of 7.
Okay.
And then you use a calculator. You have a calculator? Okay. Then you use a calculator. Well, don't use your phone. You can, but
Is that accurate?
it's tough. No, it's accurate if you know how to do it. But you gotta pay attention how you type it in on your phone.
Okay.
All right? You good?
Yeah, good.
All right, I'm gonna leave you with that.
Okay, thank you.
You're welcome, baby. Kyle, let's take a last look. What'd you get?
I got stuck.
Okay. That's fair. What do you multiply top and bottom by?
By what, by 2 plus square root of 6.
Perfect. Okay, so make sure you grab, I would say 8 donuts, but make sure you grab several donuts on your way out. Don't take them home though, 'cause your dad, I'm gonna help your dad.
Oh, yeah, good point.
2 times 2 is 4, minus 6, yeah? You agree?
Yeah.
Now Kyle, I got 8, 2 plus the square root of 6, over negative 2. Alright. 2 goes to 8 4 times, so this is negative 4. 2 plus the square root of 6, which is negative 8 minus 4 square root of 6. Bye, sweetness. We'll see you later on. All right. When do you think you're going to take it, Casey? When do you think you're going to take it?
Probably either today or tomorrow.
Okay. I'm going to text your dad when I leave here.
Okay.
All right, bye.
Have a good day.
See you. All right. Kyle, you good? All right. Kyle, I'm going to leave you with that. Tyler. Kyle, make sure you grab some donuts on your way out. Fuck. Kyle, take the whole box. Tyler, you're not going to take any, right?
I'm good with you.
Okay. I mean, you want to take them, Tyler?
It doesn't matter.
Okay, let me ask you this, Tyler. If you take them home, do you have somebody there who will eat them, or are you going to throw them away?
I don't see what I eat.
Okay. Kyle, take some with you, and then I'll get the rest of them to Tyler. Whoever stays last is the one who gets the donuts. All right. Sine A plus B. Sine A plus B is sine A
It's like 3 over 5.
cosine B plus sine B cosine A, right?
Yeah.
So it's 3 fifths
Times negative 3 over 2.
times negative 3 over square root of 3 over 2 plus 1/2 times 4 over 5. So it's negative 3 square root of 3 plus 4 over 10. Take care, Kyle. Thanks for coming, man. You good?
Yeah, I'm good. I got how to do it. It was just, I knew it was messing me up on that, but
And then this one, what'd you get?
it'd be 4 over 5 times negative square root of 3 over 2.
So it's negative 4 square root of 3 over 10 plus
Plus or minus?
plus. If it were plus, it'd be minus. Minus is the other way.
Oh, okay, I did that wrong.
All right. Plus 3 tenths. So it's negative 4 square root of 3 plus 3 over 10. The way I remember it is, I know that cosine A plus B is cosine squared minus sine squared, right? Because if it was cosine squared plus sine squared, it'd be equal to 1. That can't happen. So cosine 2A is cosine squared A minus sine squared A. And then the minus cosine switches it around. And it goes opposite.
I got it.
All right? I appreciate your time.
Thank you. You have any tips for calculus ones?
Study your ass off.
Alright, that's the thing. That's my only class this summer anyway. So I have. Like,
You taking it this summer?
yeah.
Who's teaching it?
I don't know. I didn't take my schedule yet.
Oh, but you're doing it at UCF.
Yeah.
Yeah. No, I mean, here's the deal. It's not bad, but you want to stay on top of it.
I don't want to pay for more classes. I'm just trying to get done the first time.
Yeah. Well, like I say, you got my email address, you got my phone number.
Thank you.
If you need anything, just hit me up.
I will.
All right? And I mean that. Don't sit there and struggle.
I will. Thank you.
You're welcome, Tyler. Take care.